Now, since gravity is not a force as Einstein thought by his equivalence principle, and since there is nothing in space to carry gravity, he realized, as smart as he is, that gravity is actually carried by space itself. And how is that even possible? What is gravity? Now, let's imagine that you have this two-dimensional plane, and this will resemble space-time. Let's think of it as space-time and recall from special relativity that Einstein united space and time into one thing called space-time. Let's imagine we have this straight fabric of space-time, and we place an object of very big mass. What would happen is the same as what would happen if you place a bowling ball on a trampoline, or if you place, let's say, some kind of metal on a sheet of cloth. It will bend downwards. And this is exactly what happens to space-time when there is a massive object like, let's say, the sun or earth. The presence of mass will warp space-time around it. It will curve space-time, as you can see over here. Now, this is a two-dimensional representation just to make it easier to understand, but really this happens in 3 dimensions, but it's hard to visualize. So let's just imagine this in 2 dimensions. Now let's imagine an object. Let's imagine an object was following a straight line through flat spacetime, and then it came around the curved spacetime because of this mass. What would happen is that the object will start to curve and follow spacetime as it curves around this mass. And this is gravity. Gravity is the result of mass warping spacetime about itself. So, if you look here carefully, you're going to realize that the distance from this point to this point is a line, but it's not straight. This line over here is called a geodesic. A geodesic is the shortest distance between 2 points on a curved surface. And you can think of it as being the same as what you would describe a straight line on 2 dimensional plane. So objects in orbit, or objects as they come about curved spacetime, they follow the path of a geodesic. And Einstein went even further, and he said that light, as it is passing through very massive objects, it will bend a, it will bend a little around it. It will follow a geodesic path. And this was against what Newton originally thought, because light had no mass. How then could gravity attract it if gravity is actually a force? But then scientists used the fact that light bends around massive objects to prove Einstein's theory of relativity. They actually did this. They measured the bending of light around massive objects. And this is gravity. In Einstein's world, it is very geometric. You can visualize it. And though Newton gave us mathematical formulas, Einstein gave us the physical visualization of how gravity actually acts.